All right, what a great talk from David. Before we get started on our next talk, please raise your hand if you are a parent. Do we have any parents in the house? All right, awesome, seeing some hands raised. This next talk will be for you. So researchers have attempted to track and identify stages in baby development for centuries. And while huge strides have been made in brilliant minds, we still have so many questions to answer. AI technology is proving to be especially promising in one particular field, and that is communication. Here to give us a firsthand look at the future of early childhood language and growth through the lens of AI, please welcome co-founder of Ubenwa Health, Charles Onu, and co-founder of Babbly, Maryam Nabavi.
Hello, everyone. Good to see you all and be back after 3 years in person. I'm very honored to be here today as one of the Voice AI founders here, headquartered in Toronto with Charles, who came all the way from Montreal. Maybe first we can start by introducing ourselves and a bit of background about our companies. My name is Maryam Nabavi. I'm CEO of Babbly. We are a data platform that help families, young families, to track their child's development. We're starting with speech and language development, and through our app, parents can upload a soundbite of their child. Our AI is able to analyze the sounds that babies make and give them an analysis of what kind of milestones they have. We are also able to give them an opportunity to speak with a speech-language pathologist as a coach, should they have any concerns. Very quick background story. I started this as a first-time parent when my son wasn't meeting his speech and language milestones. And I realized that there are no objective measures, no thermometers, if you wish, to know if my child was delayed. And I had no idea where to go. So that's about Babbly. Charles, you have an amazing founding story. Why don't you tell us about your company?
Yes, definitely. Thank you, Maryam. And nice to see you again after a while. Last time was on a Zoom screen.
Totally.
Hello, everyone. Yeah, so my name is Charles, and I'm a co-founder of Ubenwa Health. And at Ubenwa, our goal is to essentially make the infant cry a vital sign, so sort of taking care of the babies before we hand them over to Babbly. And at the earliest point of life, allowing physicians to detect the earliest signs of pathologies like neurological injuries and respiratory injuries by simply looking at an analysis of the infant's cry sounds. So I started working on Ubenwa as a result of a number of professional experiences, so not personal in my own case, but going from Nigeria, where I was born, to volunteering with NGOs that focus on health problems, and really realizing that babies are at this point in their lives where they cannot communicate in the way we adults can. They cannot, speak words. And when they're hungry, they cry. When they're sleepy, they cry. But also, what is not well known is that the medical conditions that affect them also reflect in their cry sounds. And so this is what we're trying to achieve at Ubenwa, to extract these acoustic biomarkers and use them to provide physicians with input for early diagnosis and detection of problems. Yeah.
Very cool. Maybe you can tell us, I'm curious to know, why do you think AI, voice AI, made sense in your context for analyzing the cry of the baby?
Yeah, totally. In the case of infants, there's this unique thing that's happening, because what's not well known is that newborns' cry is an involuntary response to stimulus. They don't control it. An infant cannot choose to speak louder or softer or change the variation of their cry sounds. And so it's directly coordinated by the central nervous system. So what basically happens is when the baby is crying or is experiencing a medical condition that affects their central nervous system, this changes the patterns in their cry. And so this is where AI comes in, because many of these patterns are not as audible to the human ear, whether it's pitch changes in the voice that indicates pathology. And so AI allows us to really learn complex patterns that would otherwise have gone unnoticed. essentially. And so this is where it really comes in, is identifying these signs that are subtle but are there, and that the human ear would otherwise not have been able to pick up, because babies have essentially evolved over time to communicate their health needs through their cry. And now it's time for us to use today's technologies to really extract those insights and learn it. I would love to know your family story.
It's quite
So,
fascinating.
yeah.
We met a month ago, maybe, or less than, and we realized we came to similar area but very different problems. You guys are looking at patterns of cry to screen or diagnose pathologies, and we're looking at patterns of speech, early signs of speech, which is post-cry, babbling. And a lot of people think, babies make random noises and it's babbling, and then eventually, magically, words emerge. And it's not quite like that. What we found fascinating was, no matter what the language and cultural background of babies are, whether they're born in a Japanese-speaking family or a German-speaking family, all babies go through the exact same patterns of speech. So they go from, of course, crying, but then eventually to putting vowel sounds together, then single-syllable babbles, duplicated babbles, and variegated babbles. And these are, jargons for early language acquisition. But essentially, they combine vowel and consonant sounds in the exact same patterns. And that's what's had significance in terms of development. And those were the early biomarkers that we knew humans are not good at recognizing. If you ask an average parent whether their child, what stage of babbling they're at, they wouldn't know. It requires pattern recognition over a long period of time, and consistent monitoring of the child's speech to track that. So I'm curious, what have you guys learned? What are the different kinds of cries? What kind of pathologies have you been able to, or any other insights that you can share?
Yes. So it's a big space we are in. We're trying to detect medical conditions from the infant cry sounds. But where do we start from? We started from brain injury, because one of the things our team has spent time looking into is physiology and mapping medical conditions to the central nervous system and seeing which ones have an impact on it. And the ones that affect the neurology, the brain, are some of the strongest, the ones which we have the strongest evidence for. And so we've been able to show that, for specific conditions that cause neurological injury, we can detect from just the cry sounds with up to close to 90% accuracy, which offers just a significant improvement from, the typical physical assessments that you would do to decide to triage this patient, for instance, to an MRI machine and so on. So from this first example, it gives us like very strong, hope for the future in terms of what we can do and expand from not only neurological conditions to respiratory conditions and other infections that sort of ultimately impact the central nervous system in babies. I'm curious I'd love to know what your own experience has been.
That's really interesting.
Yeah.
We're looking at it from a slightly different angle. We're not diagnosing conditions. However, we're able to screen for potential risks. And the first condition is speech and language delay, which is very prevalent. Actually, 1 in 10 children experiences some sort of speech and language disorder. And as early as 9 months, we can tell if a child is at risk or not. And by putting the parents in the right direction, giving them the resources and the coaching so they can apply the strategies and play with their child in a particular way and repeat those strategies, we're able to close the gap between that child and their peers if they would not have received intervention. So for us, it's all about early screening, and we do understand that there might be false positives, but we think the benefits of giving the parents the coaching and these play-based strategies far exceeds the risk of the false positives, as an example.
Yeah. And that's part of the balance too, is in tuning these algorithms, because they will never be perfect. And then one must think about the costs on both sides. What are the costs of false positives or true negatives? And if it basically means the baby gets more attention and more care, then it's okay, and it allows us to do even more for them.
Yeah,
pretty cool.
Yeah, one thing I'm constantly being asked when we meet with parents is, they think this, or other founders even that are outside of this space, they think AI is this box, black box that can do everything, and whether we can, in our case, whether it's able to say if a child is likely to develop autism or apraxia or stutter, and we always have to kind of explain, the limitations of this technology and what we can and cannot do. I'm curious if you also face the same situations, and what do you think AI cannot do that humans can do better?
Yeah, no, totally. And there's so many challenges in deploying technology like this. Like just going from, okay, yeah, there's a proof of concept, and then this is how it's going to work in practice. Because I could just say people would have greater expectations. Even if you can detect only a specific range of critical conditions, it's still not a magic wand that can tell you that all is well and all is good. And you can imagine lawsuits coming out of that too if it says all is good and someone says, oh, but it says all is good and my baby got sick. And I think the biggest challenge that we've probably encountered, we're thinking about actively, is that way in which the AI will collaborate with physicians or parents to deliver the purpose. How much information is too much information in terms of these clinical biomarkers we are looking at? How much alerts is enough alerts to say that, yes, this baby needs attention, and tuning that threshold, because there's evil on both sides. You don't want to raise too much alerts, and then it becomes this thing that just raises many false alerts, and they don't care anymore about it, the physicians. But also, you don't want to go to the other extreme too, where you miss many patients that would have otherwise been caught. And so it's really designing that system that allows us to achieve those goals of optimally communicating what matters, when it matters, and at a frequency that allows it to be really useful in the care flow, because humans have to be involved. And so it's really fitting it into the way they operate and to their things, yeah. I guess your case will largely be with parents, and what would you say are the challenges that you've seen in the deployment and putting up this deployment?
Yeah, for us, I think as much as AI is really good at least what we discovered in pattern recognitions for speech, it's not good at context and understanding, what are the developmental background, family history, how much language, nutrition a child has been given. And also, something that's extremely important in this context, and I'm imagining for you as well, is the parents' readiness to accept and to, be an ally and partner with, whatever service or tool that they're using. Because without their acceptance and without their partnership, we can't really make any progress. And that's not something that, we can solely rely on technology. It requires, in our experience, a speech-language pathologist or a coach can develop that initial trust with a family to, give them directions on, whether their child is delayed or not. So we try to not be very prescriptive in the app because we know just telling the families that their child is at risk without context will not be very well received.
Yeah, totally. And I can relate to that and to the question of context, because context that a toddler is growing up in could make a huge difference as to how fast they acquire language and so on. I have a 5-year-old nephew now, and he's largely grown up in a household of adults and has had no children his age to play with. And we've noticed he's just slower in acquiring language versus the other ones who've had children around them and get to play around. And I guess these are some of the things that AI cannot incorporate into its decision making and how to improve the care the person gets ultimately.
Yeah.
Yeah.
So what's next for Ubenwa?
So there's a few paths forward for us. One is really making sure that we exhaust the things we can do with the infant cry, and that's a lot from our findings so far. Going from just detecting one condition that results in brain injury to other things that could alert physicians of infections, of respiratory difficulties, of congenital conditions that would have gone unnoticed at birth. And so really just expanding that suite of pathologies that we can detect from the cry sound is one key path forward. And primarily on the one that we've sort of built now, the brain injury detection, it's moving forward to the process of FDA, Health Canada, getting that approved to be able to bring this into the healthcare system. And yeah, so those are like two parts, like vertical and horizontal path for us going forward. And we're really excited about the possibilities here because, ultimately, we are seeing a world that can be created in which the infant cry now becomes a vital sign, essentially. A sign that not just a sign that we try to quiet as soon as the baby is crying, but that we try to extract insights from because it can tell us about what they want, what they need, and what their body is doing, essentially. And if it's a vital sign, then making it really widely accessible. If you think of the other things we call vital signs today, like temperature, blood pressure, we not only monitor them day in, day out in the healthcare settings, but now we have them at home with various sensors from wristwatches to custom devices and portables, baby monitors, and so on. And so that's what we want to come to as well with baby cry sounds. If it is a vital sign, if it holds deep insight of the infant's physiological health, then we want the whole spectrum to be able to have access to it, from physicians to parents, from developing countries to developed countries, and that no baby gets born or gets pushed into the world without having their cry analysis as like a critical screening step going forward. So we're excited about like working to create that world. Many challenges along the way, but definitely looking forward to that for sure. I'd love to know what excites you in the future of language development.
I mean, honestly, what you just said makes me so excited. I jump off of my chair. Obviously, I'm biased, but the thought of, children or babies not being released from the hospital without their cry being analyzed, it's kind of like, back in 50s, children were not allowed, were allowed to get released from the hospital without their car seat, and now they can't. Yeah. So I feel the same thing needs to happen when it comes to their development and biomarkers. For us, I think we serendipitously landed on an opportunity that we are really excited about. It's very ambitious. I call it the moonshot of baby development. But we realized that parents were sending videos to whether it's their pediatrician or speech-language pathologist to show them why they're concerned and when they would see something odd. And the speech-language pathologists were able to detect the patterns really quickly. Of course, they're trained. They would look at, certain signs of like flapping the children's hand or, excuse me, not making enough eye contact, not following the direction of the sound. So we believe there is a huge opportunity to use the data that parents are already sharing with us and combine that with the assessment. I think I lost my... Yeah. Okay. With the assessments that the therapists are providing and be able to train new models that are able to not just take a baby's babbling as an input, but potentially look at other biomarkers like body language, eye contact, etc. Again, it's a very ambitious thing, but yeah, it's what really makes us excited. And the other thing that I also agree with you is one thing that keeps me up at night is, hopefully this tool will become standard practice for everyone. But the reality is not everybody around the world is using a smartphone. So how do we make this technology accessible to as many families around the world as possible, because either they don't have access to socioeconomic conditions, they're living in those conditions, or because of the political climates that they're living at. Even today, people in Iran were denied access of internet. So even if you have a smartphone, you can't have access to basic technology that we take for granted here. So that is something that keeps me up at night, but I'm very hopeful that integration with healthcare system and devices around the home hopefully will make this dream a reality.
Very nice. And I think it's really interesting. I didn't think of that part of you talked about gestures also being a part of this language assessment. That's going to be really interesting to see that come to be, the video analysis,
Yeah, again, like we have smart cameras around our homes. We have smart speakers sitting in our homes, but yet they're being underutilized. I think, you know, there's so much that we can do with these technologies. We have the infrastructure here, at least, and parents are hungry to get more insights and data. So hopefully we can take the myths out of baby development and make it more scientific and objective.
Yes, totally. I see that we're out of time before someone grabs us. Let's let's continue the conversation later on. Well, thank you so much.
Thank you.
Yeah.